Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 1 Notes 5, which is on Pythagorean means. Today we are talking about a bunch of different kinds of means that are used out in the world depending on what kind of data you are working with. You and I and most people are very familiar with the arithmetic mean. The arithmetic mean is the most common mean that we have. It's the mean where we add up all of our data and then divide by the number of data points that exist, and that gives us that mean that we use. It's the mean that's used for calculating our grades and calculating a whole bunch of other stuff. But like we talked about back in the measures of central tendency lesson, there are a lot of other ways of calculating a center. So there are 3 other means that we are going to talk about today and what they look like and what their formulas are and how we use those formulas and what they're used for. So the first one that we're going to discuss is called the harmonic mean. The harmonic mean is when you take n, which is the number of data points, and divide it by the sum of the reciprocal of each data point. Okay, so that capital sigma, we talked about capital sigma back when we were calculating the actual mean. This guy right here, that tells you that you're finding the sum or you're adding. This 1 over x is just each data point, okay? So 1 divided by x is going to be the reciprocal. If you remember that word reciprocal is when you flip a fraction upside down, okay? So we use the harmonic mean when we're looking at rates of change. We use it with velocity, we use it with speed. A lot of things in physics come with the harmonic mean. So let's just practice finding the harmonic mean and calculating that, what that would look like in the formula. So here's your formula right here. And by the way, you do not have to have these formulas memorized. These formulas will be given to you on the test. So you don't have to have them memorized. You just have to be able to apply them. So the first thing I need to figure out is what is my n? And it looks like my n is equal to 4. Now each one of these is your x. Each one of those is a data value. So if I'm plugging this into a formula, my harmonic mean is going to look like 4 divided by, and then the reciprocal of each data point. So the reciprocal of 9 would be 1/9. The reciprocal of 12 would be 1 over 12. The reciprocal of 16 is 1 over 16. And the reciprocal of 20 is 1 over 20. Okay, so that's what the formula looks like. It's not hard to plug in. It's not hard to put things where they need to be. The hardest part for you is going to be typing it into your calculator. If you didn't have your calculator out before, you definitely need to have it today. So go ahead and pause this so that you can find that calculator and get it out. So on my calculator, what you have to do is remember that the fraction bar separates the top from the bottom. Okay, so I can't just straight type this in how it looks. It's not going to work that way. There's a whole lot of brackets and parentheses that you would need to make it work if you were going to try to type it all in at once. So I'm going to do this in pieces. The first thing that I'm going to do is take care of the bottom. Now, I need to put each individual fraction in its own set of parentheses and then put an addition sign between there. So I'm going to open a set of parentheses and type 1 over 9. 1 divided by 9, close that set of parentheses, then hit plus. Then I open a set of parentheses and type 1 divided by 12, close that parentheses, hit plus. Open parentheses, 1 divided by 16, close that parentheses, hit plus. And then open a parenthesis one more time, 1 divided by 20, close that parenthesis. And now I'm going to hit enter to give me that decimal. Okay. So here's what I get when I do all of that. I still have the 4 on the top. I have not touched the 4. I end up with a decimal in the denominator of 0. Sorry, I should put my 0 in front so you can see the decimal point. 0.3069, and then the 4 repeats. Keeps going. Okay. Here's the thing. Don't hit clear. Do not clear your calculator. Leave that decimal in your calculator. Your calculator is only showing you a few of the digits that exist in this non-terminating decimal. This decimal repeats. It goes on and on and on forever. And your calculator knows more of the digits than it's showing you on the screen because it's limited on the size of the window. So you're only seeing a few of the digits. then you have to, if you're going to leave the decimal in the calculator, you have a more accurate answer because your calculator knows more digits than it's allowed to show you. Okay, so don't hit clear. Your best friend in this class on your calculator is going to be the second answer button. If you look on your calculator in the top left corner, you'll see a button that says second. That gives you all of the things that are above your individual buttons. Then down on the bottom, if you look above the negative sign, you should see ANS, which stands for answer. So I'm going to use that second answer button quite often in this class, and today is going to be my first example. So down here, I'm just going to write you what those keystrokes will look like. So the next thing I'm going to do is I'm going to type in my 4. Just hit 4 on your calculator. The decimal will disappear, but your calculator still knows it, so don't worry. So type the 4, then you're going to hit the divided symbol because that's what the fraction bar is. Fraction bar is division. So then you're going to hit divided by. Then you're going to hit the second button, and you're going to hit that answer button, which is above the negative. So look for the one that's above the negative. That's going to pull that previous answer. It pulls your most previous answer that you typed into your calculator, and then you can hit an equals or enter, whatever it looks like on yours, and that gives you the harmonic mean. So when I type that in, I get 13.03. Okay. We would typically use the round off rule here, so that would tell me that I need to take that 3 and I need to use it. I'm going to switch to a color that's a little easier to see. Take that 3, use it to round the 0, and it's really just 13.0. Okay. Do this with me. I want you to practice this on your calculator along with me. Don't just watch what I'm doing. It's really important that you're able to type these things in on your calculator on your own. One other thing that I want to point out, take a look at the mean that you got. The mean that you got is 13.0. The data that you have is 9, 12, 16, and 20. It makes sense to me that your mean would be somewhere in the middle of those numbers, okay? So that's the other thing to kind of spot check. Make sure that your mean makes sense. If it's not in your data range, if it's not in the range of your data, then you did something wrong. It's still a measure of central tendency. It still should be somewhere in the middle of whatever your data set is. Okay, so then the next thing is, let's take a look at part B. I have an n of 3, so my mean is going to look like this. I have 3 divided by 1 over 4 plus 1 over 10 plus 1 over 25. Okay, so the first thing that I have to do when I'm typing this into my calculator is, again, put these things in parentheses in the bottom and add those together. Once again, I want to say don't just type everything in at once. You need a lot of brackets and parentheses if you do it that way, and you have way more of a chance of making a mistake. The more you type into your calculator, the more chance you have of making a mistake. Is really what happens there. All right, so I have open parenthesis, 1 divided by 4, close it, plus. Open parenthesis, 1 divided by 10, close it, plus. Open parenthesis, 1 divided by 25, close it. I'm going to hit enter. I get 0.39. It's a terminating decimal here, so that helps. 3 divided by 0.39. All right, so now, just for practice, now typing in 0.39 as a terminating decimal is not hard to do, but just for practice, I'm going to use that second answer button again. So I would hit 3 divided by second answer, and then I get an answer of 7.6923. I would use the 9 to round to the 6, which gives me 7.7 for mean there. And again, you should look at your data. It has to make sense. It has to fall in the range. I've got a 4, a 10, and a 25. So it makes sense to me that 7.7 would be the harmonic mean. All right, let's try one more of these. So in part C, I have 1, 2, 3, 4, 5. My n is equal to 5 there. I'm going to go ahead and erase this stuff. So hopefully you got that written down. Those are your calculator keystrokes in case you missed them. Remember, you can always back up the video if you need to. Okay, so my n is equal to 5. So my mean looks like 5 divided by 1 over 3.7 plus 1 over 12.2 plus 1 over 18 plus 1 over 30 plus 1 over 45. Okay, I never make my fraction part long enough. All right, go ahead and put all those parentheses, all those fractions and parentheses in the bottom, and then you're going to type them into your calculator. So open parenthesis, 1 divided by 3.7, close it, plus, open parenthesis, 1 divided by 12.2, close it, plus, open parenthesis, 1 divided by 18, close it, plus, open parenthesis, 1 divided by 30, close it, plus, one more, open parenthesis, 1 divided by 45, close it. Hit enter. I end up with 5 divided by 0.4633, and it keeps going. So this is, again, a place where you're going to want to use that second answer button. Second answer. So now I'm going to type into my calculator 5 divided by second answer, and it pulls my previous answer that I just hit on the screen, and I get 10.7910. It keeps going. I, this time, need to round to the hundredths place because I have data that has a tenths place. So I'm going to look at the thousandths place to round to the hundredths place, and my mean is 10.79. I think we talked about this symbol the other day, but just in case we didn't, that symbol right there, it's a little bit different than the equal sign. It's actually an approximately equal to sign. Approximately. Does anybody else have to say words out loud in order to spell them correctly? Approximately equal to. That's what this symbol means. Anytime you're rounding, anytime you factor rounding into your process, which hopefully you're only rounding at the very, very end. That's the goal. You want to round at the very, very end. So anytime you're rounding, you're going to switch to that approximately equal to sign. Now, would you be marked incorrect if you didn't write approximately equal to? No, but technically speaking, it's not truly equal anymore. So that's why you will see me use this symbol quite a bit. I use the approximately equal to anytime I round, or at least I try to. All right, move on to the next one. So now I'm going on to the geometric mean. So if you think back to Algebra 2, at the very end of Algebra 2, you may have talked a little bit about nth roots, where you had an index other than 2. Okay, so when you have a number in front of your radical sign, that is called your index. Okay, when we're doing square roots, which is the most common thing that we do, our index is 2. We don't write it because it's kind of like writing x to the first power. X to the first power is implied, we know that. Since square root is the most common radical that we use, we don't have to write the index of 2 because that's the one that is used most often. However, there are times that we use another index. So in this case, in the geometric mean, we're gonna use an index of whatever number of data points that we have. So n is still gonna be your number of data points. Just like it has been in every other lesson, and just like it will be for the rest of this trimester. N is always your number of data points. Okay, then the thing that goes underneath that radical sign is the product of all the data points. If you forgot the word product, that means multiply. So I need to take the data points and I need to multiply them together. All right, if I were gonna read this out in words, it would say the nth root of the product of all the data points. This is a mean that is used in business. It's used with money, economics, rates of change for economic purposes, average ratios, things like that. This is a mean that we use in money. Let's do some examples. We're going to learn some other calculator keystrokes here because we're going to need to find that nth root on your calculator. So first thing is, what is your n? In part A, my n is 3. Now let's plug it in. My mean is going to look like the third root of 5 times 24 times 35. Okay, now I want you to look at your calculator. For most of you there's 2 different ways that you'll find this. It depends on what calculator you have. If you have a scientific calculator, a calculator that just has the small window, one of those little calculators that's about $15. If you have one of those, here's how you type in your nth root. You're going to type in the root first. So in this case, I'm going to type 3. Then on the left-hand side, And I'm finding mine so I can look at the right one. So on the left-hand side, right above the caret key, you see the symbol that looks like X with the radical. But remember, to get anything above a key, you need to hit the second button. So you have to put your index in first, then you hit the second button, then you go ahead and find that stuff. Then inside parentheses, which let me see if it actually gives you parentheses. So on mine, I would have 3 and then second and then X with a radical, and it does not. Mine did not give me parentheses. So I'm going to open a set of parentheses just to be sure that they all get underneath there. And then I'm going to type 5 times 24 times 35 and close that parentheses and hit your equals button. 5 times 24 times 35, close it. I end up with a mean here of 16.1342, ... My data is whole numbers, so I'm going to round to the 10th place. That's approximately 16.1. That's my answer there. Okay, so this is the key. These are the keystrokes for scientific calculator. Okay, if you are using a graphing calculator, here are your keystrokes. Graphing calculator, you still have to put the index in first. So the first thing you're going to type is the 3 because that's the index that we need. Now, on your graphing calculator, on the left-hand side, you'll see a button that says math. Go ahead and hit that math button. You're already in the math menu, which, by the way, later in this year, you're going to use that probability menu, but we don't need it right now. You're already in the math menu, so you just need to arrow down. On my calculator, it's option 5, but you're looking for this one. So it's probably option 5, or depending on the age of your calculator and what operating system you have, it could be different. You don't know. But anyways, you're going to arrow down until you see that. Enter on that, and it's going to pull it to your home screen. Now you can go ahead, open your parentheses, and type the 5 times the 24 times the 35. Close your parentheses, and you get the same thing. I got 16.1. So those are the 2 different keystrokes based on which calculator you have, and it's going to be different for each one. All right, let's try the next one, and we'll just practice typing this into the calculator again to make sure that we all get there. So my mean is going to look like, in here, I have 1, 2, 3, 4. My n is equal to 4. So I have the 4th root of 18 times 14 times 16 times 13. So again, type your 4 in first, go find this wherever it is depending on your calculator, then open your parenthesis, type the 18 times 14 times 16 times 13, close your parentheses, hit equal, and let's type all that in. I'm going to try it on mine. So 4 math, option 5, 18 times 14 times 16 times 13. And my mean here, I get 15.1304, blah, blah, blah. It keeps going. Now I'm going to use my rules of rounding. I need to round to the 10th place. So that's approximately 15.1. And does it make sense with my data? Yes, it absolutely does. 13, 14, 16, and 18 makes sense to me that my mean would be about 15. All right, one more practice of this one. 1, 2, 3, 4. So my n is 4 again. I have my mean is equal to the 4th root of 1.1 times 1.08 times 1.12 times 1.07. I'm going to type that in. 4th root. So I hit the 4, I hit math, I go down to option 5, or if you're using a scientific, you do second and the caret key to get that x with a radical sign. Now underneath, 1.1 times 1.08 times 1.12 times 1.07. I end up with 1.09233 dot, 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 keeps going. Okay, you've got data that's in the tenths place, but you also have data that's in the hundredths place. And since you have data that goes out to the hundredths place, that means I need to round to the thousandths place. That means I'm looking at the 10,000ths place to go up from there. So my mean, my geometric mean here is 1.092. All right, one more mean that we're going to look at. So the quadratic mean, this is the last mean that we're going to talk about today that's new. The arithmetic mean is one that you already know. So the quadratic mean is the square root of the sum of the data points squared divided by n. This is also known as the root mean square. This is something that's used in physics when we're talking in terms of voltage or currents. You'll see this in other areas of statistics as well. If you go on and take statistics classes beyond this class that we're in, you'll see the quadratic mean quite frequently. What happens here is that we're adding the data up, instead of just adding the data up and dividing it by dividing it by n, which is what the arithmetic mean is, we're adding the data squared. And since we're adding the data squared, we have to go ahead and undo that by taking the square root. And that just factors in the variation of the data a little bit more accurately than just taking the arithmetic mean where you add them all up and divide by how many there are. So if you square them and add them and then divide by how many there are, and then you take the square root of that, you get a little bit better picture of the variation. Okay, so that's the reason for that. Now let's take a look at how we would type that in. So in part A, and this is, by the way, just straight up square root. None of that finding the nth root stuff in this one. This one is just square root. So this one, if I'm going to set it up, my mean looks like I've got an n of 3. So my mean, make yourself a big old radical because you're going to need stuff on the top and the bottom. So on the top, I have all of the data squared and then added together. So 22 squared plus 15 squared plus 11 squared. In the denominator, I'm going to divide by n. All right, now there's going to be a trick to typing this into your calculator. Once again, you have to follow the order of operations. You have to make sure that you use parentheses. I do not recommend typing it all in at once. You can, but there's a lot of brackets and parentheses that you would have to use to make sure you get an accurate answer. So what I'm going to do is I'm going to start with this top. Okay, because remember, fraction bar splits top from bottom. So I'm going to start with the top. I'm just going to take those three and type them in. 22 squared plus 15 squared plus 11 squared. I end up with a number of, oops, sorry, I didn't get a square on that. 22 squared, try again, 15 squared plus 11 squared, there we go, 830. So here's what I have. Oh, and I didn't put my 3 there. Sorry, that should have been a 3, my bad. So I have 830 divided by 3. The next thing I'm going to do is, let me get that green back, this piece. So I take 830 and I divide it by 3, and that gives me 276.6 repeating. Here's where you want to use that second answer again. 0.6 repeating is a repeating decimal that goes on and on and on forever, and your calculator knows that. It can't show that to you. It's only going to show you a handful of the 6s that come after the decimal point because that's limited. It has a limited window size, but it knows more of those digits. So when I type this into my calculator, I'm going to type the square root, which for you is second, and then square root, and then I'm going to do second answer, and then equals. And then it's going to pull the whole thing. So when I do that, second square root, second answer, I get 16.63. 329, blah, blah, blah. Round to the tenths place, use your 3. So I have approximately 16.6 there for a mean. Let's try this one more time together. Okay, 1, 2, 3, 4, 5. So I have an n of 5 here. That means my quadratic mean looks like the square root of, I'm going to have a long radical here, 13 squared plus 5 squared plus 8 squared plus 10 squared plus 17 squared divided by 5. Again, I'm going to start with the top. So in your calculator, 13 squared plus 5 squared plus 8 squared plus 10 squared plus 17 squared. 647 there is what I get. So that's equal to the square root of 647 divided by 5. Take 647 and divide it by 5. And I get the square root of 129.4. Now that's an easy one to type in because it is a terminating decimal. So you could just straight type it in. But if you want to practice, find that second answer. You'd do second square root, second answer, and then hit your equals button. And that's for both type of calculator. So when I do that, second square root, second answer, I have 11.37, about 11.4 there for an answer. All right. That takes us to the end of our notes for today. Thank you so much for listening. Go ahead and work on your practice assignment. And if you have any questions, feel free to let me know. Thanks for listening, and I'll catch you next time.